So at this point, I'd like to invite all of our panelists to turn on their camera, and we can get started with the ongoing conversation for the remainder of our agenda. For our panelists, I know there was a lot to cover in only 10 minutes or so of your presentation, and so I'd like to spend a couple minutes exploring the path forward or the end game, and maybe some aspects that we didn't get the opportunity to touch on and quite in depth during the presentations. So maybe actually I'm going to start with one that builds on what Carrie talked about. Carrie talked about the importance of collaboration, using the example of collaborative contracting, utilizing collaboration to maximize the benefits of projects and initiatives. So this is a question for all of our panelists. What are some examples of the ways that you're collaborating to advance technology and innovation? And this doesn't have to be specific to technology and innovation. It could touch on collaborative aspects from a contracting perspective or beyond technology and innovation specifically. So maybe I'll kind of start in reverse order of the presentations. I don't know, or Carrie, if you want to jump in, I know you just talked about it, and then we can move to Kyle if you like.
Sure. Maybe I talked a lot about CHOA and how we collaborate and share, and I think a lot of folks online are familiar with that. But maybe drilling down a little bit more, example within Suncor is creating that platform for sharing and removing that kind of brick wall between, what problem are we trying to solve and what are the solutions. Is we've in our group in enterprise technology, we actually have hosted 2 academic forums, as we call them, for transformational technology development for energy systems, where we have invited researchers from around the world to join us for multi-day event to literally explore that kind of gap between problems to be solved and potential solutions. So, with academics, definitely an early stage research, a little different than some of the projects we talked about today. But that creating that network and that kind of open innovation, open collaboration approach is one way that we've started. And it started in 2018. And then we had our second one this year, just a couple of weeks ago, using virtual platform, which actually reduced even more barriers for people to be present and not have to travel. So that's a great example at Suncor and our team.
Yeah, thanks very much. That's a great example. Kyle, did you have any thoughts?
Yeah, for sure. So I just wanted to just point out that, yeah, MEG, we're definitely trying to advance technologies to improve both environmental and economic performance. I think a lot of times they go hand in hand. And one example, a recent example at MEG that of collaboration and trying to do exactly that is a project that we're working to get going. It's a pilot to test a catalytic process which reduces the viscosity of bitumen. So it's a surface process. It's not subsurface, but on surface, the idea is that it's a catalytic process that will reduce the viscosity of the bitumen, which obviously has benefits in terms of lower diluent requirements, and then lower transportation costs and that type of thing. So that technology came from a US company that MEG has partnered with, and we're in the process of getting a pilot going as well as securing some funding for a pilot. But as an example of a pretty exciting technology that's in the early stages at MEG that definitely involves some collaboration and could have some pretty big impacts on our operation if it's successful.
Hey, thanks, Kyle. Great example. Julian, over to you. Did you want to talk about some examples of collaboration within ConocoPhillips Canada?
Yeah, for sure. So ConocoPhillips is one of the most active members within COSIA. So for us, COSIA is a great avenue for collaboration with other oil sands producers, with universities, other agencies that provide research and development of technologies, service providers. So for us, that's that ecosystem is so important for our own implementation of technologies. I believe that there are really complex challenges in the future for oil sands. And I don't think, you know, a single company will be able to solve all those things. So I guess that, you know, if we can work together on solving those technologies and removing IP concerns and, you know, basically paving the road for more collaboration, I think we'll be able to, you know, make our oil sands assets more cost competitive, and also, you know, we'll reduce our greenhouse gas emissions overall. So for us, COSIA is a great avenue, and we'll continue working with the other COSIA partners to advance technologies.
Thanks very much, Julian. All right, Cheryl, last word to you on this question.
Yeah, great. You know, I'm reminded, you know, when we think about collaboration, I know Steve McDonald was a guest speaker at PTEC's AGM, I want to say a year or so ago. And, you know, this quote always resonates with me that he used, you know, when he gave his speech or his address. You know, alone we can do so little, together we can do so much. And so, you know, collaboration is really important for our industry today. Julian mentioned about COSIA. You know, Imperial, like ConocoPhillips, is a very active in COSIA and all of the environmental priority areas. CRIN as well. Imperial leads the Technology Enablement Committee as well. So we really see value in collaboration with our industry partners. Just to give you an example, you know, through COSIA, it's more of a mining example, so I apologize for, you know, folks that are more in situ, but, you know, our boiler flue gas project at Curl, you know, we were fortunate to get a government grant for that, but that's a collaborative project between Tech, Syncrude, and ourselves, and it really is recovering waste heat from boilers. And so a really great example of, you know, something that came out of a foresight challenge at COSIA. You know, we grabbed a hold of it, implemented, you know, the first commercial demonstration at Curl, and got partners through COSIA to advance that project. So really exciting. You know, there's endless examples of collaboration. I also wanted to highlight, you know, something else that, you know, Imperial is doing. You know, just recently we did a pitch competition with the Canadian consulate in Washington. You know, we pride ourselves in developing our own technology, and you know, as you can see, you know, we spend a lot of years in developing technologies and proving it up, but we can't do everything, and so we have to leverage others that have technology that we can use in our assets, in our operations today. And there are a lot of vendors, there are a lot of folks out there that can really help our businesses be more profitable, improve environmental performance. And so we had this challenge. So we had, you know, a number of things at Cold Lake that we would like to improve on. And so we had this pitch competition, and we had 10 leading folks of technologies, you know, lots of different things. And so gave us an opportunity of, you know, plugging into others that are working on things that are really applicable for our business that we can just buy and deploy today. So it's, you know, it's really just, you know, the whole part of, you know, collaborating and leveraging others' expertise to improve our operations and our businesses.
Mm-hmm. Great examples. Thank you. Thank you all. Okay, so I want to ask maybe one or two more questions before we look to the audience questions. Some really, really good questions are coming in. And this one is a little bit more directed at the project presenters, Cheryl, Julian, and Kyle. I know each of you talked about this a little bit in your presentation. You know, for example, Julian talked about the pilot. I forgot my numbers correctly on about 12 well pairs, and now you're looking at NCG co-injection in about 60 well pairs or so, 60 or even more. But I was hoping to maybe put a little bit of finer point on the question of commercial readiness for each of these technologies. So can you tell me a little bit about the current status as it is November 18th, 2020 today, of the commercial readiness of each of these technologies, and when we might see, if we haven't already, these technologies fully deployed at a commercial scale, maybe not across all of the resources that you have, but certainly at a commercial scale in the organization. So maybe we'll start with Cheryl on this one, if that's all right.
Just take myself off mute. Yeah, so being the research organization, there are challenges with various assets, and we work on solutions like, the cyclic solvent process, targeting, those poor quality, reservoirs at Cold Lake, and how we can develop them more with a better environmental performance. Once, our technology is commercial, what I can tell you is, we are still operating the pilot and we're still learning. A lot of our focus right now is on wind down strategies. I heard Kyle talk about, the propane recovery and really trying to manage that. That's the stage we're in right now. All of those learnings will be built into the commercial strategy when we deploy the technology. But in terms of timing, so the base technology is commercial. It's now with our development teams, and they're working that through their development strategies and plans in terms of when is the optimal time to deploy that technology at Cold Lake. So there are a lot of things that, that the asset is working, and just prioritizing, all of these technologies and the development timing for all of them within the asset right now.
Perfect. Kyle, did you want to expand on what you talked about in your presentation?
Yeah, sure. So in terms of commercialization, like, we're in the latter stages of our piloting process. The longer we keep on going, the more data and the more confidence that we have in how the process will ultimately perform. Short answer on commercialization timing is we're at least a few years away. So if we're happy with how everything's looking, there's a few things that need to happen to commercialize the process. One would be more stable and attractive market conditions in terms of mainly bitumen pricing, but as well as the condensable gas pricing. Right now, as you know, pricing is volatile, so we definitely need some stable pricing. And another big one for eMVAPEX specifically is that it has to be tied to growth. So us growing our production, it probably won't make economic sense to deploy eMVAPEX to just reduce absolute emissions and reduce SOR while keeping production stable. So the huge benefit of eMVAPEX is then deploying it on certain particular pads and then reducing steam injection to those wells, redeploying that steam to new wells, and then increasing overall production. I noted before in a long-term commercial scenario, we think that we could increase facility production by up to 75% without new steam expansion, without new steam facility expansions. Obviously, there'd be probably some emulsion debottlenecking and some other work associated with that. But we definitely need to tie this project to growth in production. It doesn't make sense otherwise. And when we look at, is MEG growing in the next little while, in the near term, in the next couple of years, it's maybe small growth, if any. It'd be more of a medium-term thing. If we can justify growing production based on market conditions, then eMVAPEX is a possible process that would be used to do so.
Perfect. That's really helpful. And Jillian, I maybe I quoted the numbers wrong from your presentation, but did you want to expand on that at all?
You got them right, Mark. So, our strategy is to shorten those technology development times as much as possible. We went from idea, concept design and pilot to commercialization in 3-4 years. Of course, when you compare NCG with, let's say, any solvent-related technology, it will be simpler in terms of facilities and cost. So perhaps, when you look at NCG, it's notionally easier to go for a commercial rollout much faster. And then, we'll keep deploying NCG. I think that technology is versatile enough that, you can dial up and down your NCG volumes depending on, reservoir response, market conditions. But we're trying to, for all technologies, we're trying to shorten that time frame. I don't think we can afford now decades to develop technologies. I think, we have to look into, faster implementation of pilots, and if they work, as a minimum viable pilot. If they work, then you scale, and then you continue scaling if it works, and if it doesn't work, then you can move on to the next thing as soon as possible. I think failing fast is important here as well. But then you got to try things and find that right combination. I don't think we'll have the silver bullet, with only one thing. Eventually, it will be a combination of technologies, subsurface, surface, that will help us become more resilient in terms of market conditions and greenhouse gas emissions.
Perfect. That's very, very helpful. All right. So my next question is directed primarily at Carrie, but certainly other panelists are most welcome to jump in if they have any thoughts. You talked about some of the cultural changes you've been seeing in the industry. I mean, I guess my question is, I don't know if this is a fair question, but was there a tipping point that led to cultural changes, and how do you see this evolving on a go-forward basis?
Thanks, Mark. Well, I think, what we've been experiencing over the last few years with the downturn, and now through COVID, and, experiencing significant demand destruction. I mean, it's accelerated what we may have thought was coming for the industry in terms of a low carbon future. It's accelerated it by, potentially decades or more. And so I think that's the big, macro tipping point for sure. But zooming in a little bit, and how on the culture side of what needs to change, I spoke about a little bit earlier, is, to get the results that we're going to need, we have to work differently. Maybe some ways we worked in the past, which were much more along linear timeframes, like we are working on with exponential timeframes now. So that requires us to work differently. So collaboration has to evolve. And, we have the great example of COSIA, with producers coming together to collaborate and deliver on environmental benefits. But, now we need to do that and more, and to drive value further down the value chains. And, one thing related on the culture side, you might be interested to know, I've done a lot of reading and research in this space. For those of you who know me, it's one of my favorite topics. Of what the #1 challenge is to deliver on breakthrough or game-changing innovations in a corporate setting. It's not necessarily a lack of funding. We have amazing opportunities for funding, like we're experiencing today with ERA and your programs and many others. And it's not necessarily a lack of ideas. I know, in the innovation space, we always talk about, well, we need more ideas. It's actually things like competing agendas, lack of experimental culture or that risk aversion, delays in decision making, and the need for a clear and shared vision of the future so that we can all be pulling in the same direction, especially in large corporations. These are internal cultural challenges, and it's not specific to oil sands. So please don't think I'm harping on our industry. This research is actually industry agnostic. And so we really do need to evolve in terms of how we do the work. One of my favorite innovation authors is Greg Sittel, and he says, innovation is combination. And so, to address some of these cultural things, we need to combine the science and the people to generate results, and combination of solutions like we're talking about here today. That's really the challenge ahead of us. And I'd like to highlight a really great example of an event that's happening later tonight. So 7 industry organizations, the young professionals from 7 industry organizations have come together, and they have created something called the Young Professionals Link in Energy Transformation. And that event is tonight. And we should be so proud of the future of our industry and the young professionals. And they're figuring it out. They're figuring out how to collaborate around energy transformation. And you should see the lineup and the topics they have covered. So I just thought it's worth to highlight that, because that is demonstrating the culture of how we need to work differently.
Is that open for registration? Can anyone join in?
Yeah, you can. I know there's a link on the CHOA website, and I'm quite sure that there's links on all of them. It's called the Young Professionals Link Energy Transformation Event, and it's put on through a combination of Canadian Heavy Oil Association, CSPG, World Petroleum Council, SPE, YPAC, YPE, and Young Women in Energy, and they're covering off all the energy transformation topics that you might want to hear about. So hopefully there's still room, and you can register. It starts at 4 o'clock today.
Yeah, that's great. I think I'll encourage the audience to take a look at the CHOA website, and maybe if someone has it handy, we can get a link pasted into the chat. So on that question around cultural shifts, tipping points for cultural shift, did any of our other panelists want to jump in? If not, we're at just about at 10:30 now. I'd like to get to the audience questions right away, but I don't want to cut you off if you got any thoughts. So feel free to jump in if you've got something to say. All right, that's great. We will move to the questions from the audience. We've got quite a number here. And as promised, by popular demand, I will start at least with the most frequently asked question, or most upvoted question. And so this is, this was asked at 9:20 a.m. So it would have been during Cheryl's presentation. But I think, this would very much apply similarly to Kyle's presentation. And so maybe I'll ask the both of you. You talked a little bit about propane recovery or solvent recovery, but I guess the question is maybe a little more pointed around solvent recovery factors or solvent recovery rates. So Cheryl, I'll let you go first, and we'll see if Kyle has any thoughts.
So what I can tell you, well, I see, are you going to recycle the recovered propane? The answer to that is yes. That's really an important thing that we will do. We've been doing that, at the pilot. And the plan is to do that in the commercial stage as well. In terms of the solvent recovery factor, I can't really share a whole lot on that right now because our pilot results are still confidential. But what I can tell you is we are observing economic solvent to oil ratios right now. And I think given the fact that we've commercialized the technology should give the audience comfort that, the recovery that we're seeing on the solvent is good enough that we feel we can move forward commercially.
Perfect. That's helpful, Cheryl. Kyle?
Yeah, similar answer to Cheryl. Yeah, to answer the first question, are we going to recover propane? Yeah, the answer is yes. It's very attractive to recover the propane rather than just having it all sent to the central processing facility and burned to generate steam, which is essentially the other option. And in our phase 3 pilot that we talked about earlier, that did include a recycle facility to capture and re-inject as much propane as possible. So yes, in the commercial plan, any commercial plans would include recycling. As far as what we've seen from the pilot, our goals going in, as I noted earlier, was to be in that 75% recovery range. And we're right in that range. Like we're can't speak to specific numbers, but we're right in that range anyways.
Perfect. Well, thank you both. I'm going to just jump right into the next question because it's a little bit of a segue. You both mentioned economics. And so the next question here, again, it came in early, so it would have originally been directed at Cheryl. But what I'm going to do, I'd like to actually rephrase it very slightly so that it can apply to each of the 3 technology project panelists. And the question is around production cost and carbon intensity benefits that you're seeing. So I think on your slides, each of you talked a little bit about greenhouse gas reductions, carbon intensity reductions, but if there's more you'd like to share on that, that's fine. I guess maybe the heart of the question then would be around production cost. Are you seeing through these opportunities production cost improvements over whatever the baseline is, if that's a cyclic steam stimulation or a SAGD or SAGD without NCG co-injection or whatever the case is? So I'll ask Julian to jump in maybe first on this one, give us his thoughts, and then we'll move on.
Yeah, for sure. Without quoting any exact numbers. If you reduce your SOR in any SAGD project, and if the cost of the fluid that you're injecting to obtain that SOR reduction is not really high, then you'll obtain a benefit in the cost of every barrel of oil that you produce. In the case of NCG, we're injecting methane. The prices, methane prices are having low over the last few years. In the summertime, they're really, really low. So, the benefits from co-injecting NCG in terms of, the cost of every barrel of oil produced is real. So, and that's, without looking at the exact numbers, the answer is yes. And as you develop more and more areas, you can maintain or increase your oil production without expanding your steam capacity, which is huge, right? So, not every single barrel of steam that you inject will make you oil at SORs of 2.5 to 3. Marginal SOR goes up and the process becomes more inefficient. So as you add new cold well inventory, that NCG will allow you to reallocate steam to those new areas, and then the cost of every barrel of oil produced goes down as well. So those benefits are real.
For sure. Thanks. Kyle, did you want to add to that?
Yeah, so for EM Vapex, in terms of operating costs, we compare back to our EM SAGD process, which is commercially used at MEG. In terms of operating costs, we think that it's going to be similar on a commercial scale, but it's really dependent on that propane recovery as well as how much of that we can capture and re-inject, like what that net propane to bitumen ratio is, for example, as well as propane pricing. Those would be the main major variables in that, but we think it's going to be close in terms of operating costs. The benefits of EM Vapex are more in terms of capital costs. So we think that this allows a capitally efficient way to grow production, because you can do it without expanding steam facilities. You just need your recycle facilities and then figure out the propane distribution. But once that's done, you can do it without the expansion of steam facilities. So it may be more capitally efficient. And then obviously on the emission side, it's definitely at a lower GHG emissions intensity than what we'd see in SAGD or EM SAGD. We think in terms of SOR, the reduction could be up to about 43% in terms of SOR reduction relative to SAGD. Now, if we look at GHG emissions, it's not quite as large of a reduction, because there's additional emissions that would be associated with EM Vapex. For example, now if we're including upstream propane production and transportation costs, for example, that would be one of the variables that would narrow that gap a little bit. But we still do see it as a significant way to reduce greenhouse gas emissions in addition to the SOR.
Yeah, great. Cheryl?
Yeah, so just building, a lot of my comments would be very similar to Kyle. CSP, is going to reduce greenhouse gas emission intensity by 90%. In terms of, comparing it to CSS, I did mention that, CSP is targeting a different resource at Cold Lake. It's more of a thick and lean, so lower bitumen saturation, or thin reservoir, but has a higher bitumen saturation. So there's two types of reservoirs that it's targeting. And both of those types of reservoirs would not be economic with CSS today. There would just be too much inefficiencies with respect to heating up, a reservoir that's really thin, whereas CSP, since it's non-thermal, it's the right economic process to be applying at Cold Lake for those types of reservoirs. So it's not economic right now with the current CSS. So CSP is the only option for us to develop those types of reservoirs at Cold Lake.
Mm-hmm. Oh, great. Thank you. Thank you all very much. I'm going to move on to the next question here. And this one's for Carrie, and it's phrased as a bit of a statement as opposed to a question, but we don't quite play by Jeopardy rules here. So statements are okay. And I'm going to ask Carrie to comment on it anyway. And the statement is that the intersection of transformational technology development, corporate innovation strategy, and new business model thinking in the energy sector is very important. So I guess the question to Carrie is, do you have any thoughts around how we can influence the intersection of these three things: transformative technology development, corporate innovation strategy, and new business model thinking for the industry on a go-forward basis?
Yeah, it's a really great question. I actually was answering some of the questions while we were going there. To me, that's the heart of it, is how do we make all these groups and teams and come together? And it does need to come from our leaders in terms of what is our shared vision of the future. You know, we do need to take that direction. But I think, you know, our jobs in technology development are to help show the art of what is possible through our work, right? So it's a bit of a balance. If we're just waiting for it to come from above, you know, our roles in technology development innovation are to also inform, you know, hey, this is actually possible through our work. And so we can actually bring those two pieces together to help inform strategy. But it is certainly a delicate balance, and that is a lot of different groups that need to come together and get aligned. But having that purpose or that shared vision of the future is so very important. And I mean, at Suncor, our purpose is to provide trusted energy that enhances people's lives while caring for each other and the earth. I mean, that can guide this conversation. And I'd also like to just say, you know, we can all be change makers. And so that's something that I enjoy championing at Suncor and at CHOA, is providing platforms where we can come together and learn and connect. I created something called the Innovation Hub at Suncor, which is completely grassroots, employee-led, really organic. And it just came from this need to say, hey, we need to be learning from others and understanding these perspectives and how the pieces can come together. So it's kind of a bottoms-up approach. And then, of course, we have the formal top-down approach as well.
Perfect. That's very, very insightful. Thank you. So the next question is, I'm going to direct this at both Cheryl and Kyle. It says it's for the cyclic solvent process, but really for both processes. You know, Kyle, you talked already a little bit about the volatility of commodity prices, but maybe to put a finer point around the availability of propane. The question is, are you limited by the availability of propane? And this is, you know, I'm curious very much in both the Christina area as well as the Cold Lake area. You know, will the scalability of the technology be limited by the supply of propane? Any thoughts around that? Maybe we'll start with Kyle, since you got mute off already, and then we'll move over to Cheryl.
Yeah, for sure. So to answer the question on whether or not we're limited to propane, the short answer is no. We think this is a process for condensable gas, so like light condensable gases, probably a propane or a butane. So there's more than one option with the way that we have this process designed and envisioned. With that said, butane has more industrial uses than propane and is generally more expensive, which is the main reason why we went more towards propane in terms of this piloting. The propane pricing has been depressed in recent years and relatively low, which again, that's why we're piloting it. And I think prices went negative there for a little while. I want to say it was 2015 or so, but they did go negative for a short period of time. So the pricing has been relatively attractive. If processes like these do go large scale commercial, there's a chance that it could strain the industry. But at the same time, my understanding is that production of natural gas liquids is also increasing. So the supply is also increasing, and there's definitely uncertainty on how fast that supply could increase relative to the demand. So there's definitely some uncertainty there, but we think that propane is likely going to be more attractive than butane, for example, in the medium to long term anyways.
Cheryl, any thoughts?
Yeah, no, I echo everything that Kyle has to say. You know, in terms of the pilot, we were trucking propane in for the test. I think, the challenge will be is getting, the quantities we need on a commercial scale to the sites, is how, because trucking will be more of a challenge on a commercial scale because you'll need a lot of trucks to support a commercial development. So having a supply into our assets will be key.
Yeah, perfect.
And just to add to what Cheryl said there, yeah, for our pilot, even we had 8 Super B trucks, up to 8 Super B trucks per day delivering propane to site, and then we're storing it on an on-site bullet with 2 offloading stations. We have 2 trucks offloading at the same time. So the trucking definitely gets challenging with the larger scale the project is. So yeah, the assumption is that some sort of pipeline system would be required in a large commercial scale.
Yeah, and that enables significant scalability potentially. Okay, so this next one is directed at Julian, and I'm not going to make you do math, Julian, but the point of the question is that you're injecting methane, a non-condensable gas, which has a high global warming potential. And the essence of the question is that the McMurray Formation is seen as a long-term carbon trap or sink. What is the plan? What do you do with the methane? Can you draw it down? Do you leave it in the reservoir? Does it end up being sort of a GHG liability going into the future? Any thoughts on that?
Yeah, so eventually that gas, we'll have the choice to recover that gas in the future or keep it in the reservoir when we abandon those areas. We haven't put a plan in place for that yet. As of now, we try to maintain as much of the NCG that we inject. We try to maintain that NCG in the reservoir. We don't want to see a lot of recycling because there wouldn't be any point at spending money injecting NCG just to get it back right away. So we want that NCG to stay in the reservoir, insulate in the chambers, migrating to the top water deep zone. Eventually, who knows what's going to happen with the gas markets. If the gas prices go up, there will be an incentive to produce that methane back. I don't know, if we can use, those reservoirs as a way to capture methane or CO2 in the future. As per the regulations right now, they are not deep enough to be considered carbon capture and storage scheme, but who knows? I mean, that will depend on the regulators. But as of now, we're not making any plans to produce that methane. Eventually, we'll have the choice, but we're not putting any plans in place at this point.
Mm-hmm. And so, since you're on the topic, another question a little bit further down the list, which perhaps is related, is around: do you have other options for non-condensable gases? For example, could CO2 be used as a non-condensable gas for what you're trying to accomplish?
Yeah, that's right. So, CO2 is corrosive, so it will have more issues when it comes to surface facilities, wells, well integrity in general. For methane, given that it's the same fuel gas that we use, to generate steam, we have gas facilities coming to all the wells in Surmont. We have basically all the infrastructure developed for gas lift when we start the SAGD wells, and we operate them for the first 2 years. So everything is ready for methane as an NCG. We could use nitrogen, we could use CO2. Perhaps propane wouldn't do the same thing. I think propane, as Cheryl and Kyle have described, it has different applications and a bit more expensive. But in general, methane is inexpensive, and we have all the facilities ready to handle methane as an NCG. So, probably no point at looking at, CO2 or nitrogen or any other type of NCG for this.
Yeah, thanks very much, Jillian. So the next question, I'm going to jump right to the next one. We've got about 12 minutes left. I'd like to get a couple more questions in, but this next one wasn't directed at anyone specific. I'm going to go out on a limb and ask both Cheryl and Kyle to maybe take a stab at this one. So often comes up when we talk about vapor recovery processes, kind of along the lines of what you might refer to as in situ upgrading or partial upgrading or whatever. But are either of you able to comment on whether you've seen asphaltene precipitation in the pilot tests that you've run?
Yeah, we haven't seen any evidence of asphaltenes at this point anyways. The thinking is that when the propane mixes with the bitumen in significant enough quantities to precipitate asphaltenes, that's happening away from the wellbores. It's happening like further away from the wellbores in the reservoir, and that when those asphaltenes precipitate, they stay where they precipitate. Like they attach to the sand grains, and they don't come with the oil to the wellbore. So then from what we see at the wellbore, we don't see any signs of plugging at the wellbore, and we don't see any signs of asphaltenes in the oil that's produced or anything like that. So, so the short answer is we don't see any signs of it at this point.
I guess maybe, sorry, Cheryl, before you jump in, I'm going to probe on that a little bit further. Is it possible that you might see evidence in the produced oil that some of the asphaltenes are left behind?
Oh, in terms of quality improvement. Yeah, so that's something that's part of the process that we're monitoring and trying to understand, but I can't speak to those results on how much, if any, quality improvement that we've seen.
Cheryl, any additions?
Yeah, no, so yeah, we did see, on the produced fluids, we definitely saw, a lighter crude getting produced back than we had expected. So, which would, you could surmise that you were dropping out asphaltenes in the reservoir, consistent to what Kyle was talking about. We did have, because we were injecting liquid propane, not a gaseous, we did see, since propane is only partially miscible with bitumen, we did see, the separation of more of a heavy and light as well. And so that did cause us some problems, when plugging the wellbore. And so we did have to manage that with injecting some flow assurance product downhole in order to eliminate the plugging of the wellbore. So we did see some of those challenges when we were producing back the bitumen and propane.
Perfect. So the next question, I'm going to jump over to Carrie for this one. You talked about innovation. I'm paraphrasing, or maybe I'm quoting. Innovation is people. And you talked about the event that's happening today. You posted a link in the chat, so thank you very much. I encourage everyone to check it out. But I wonder, can you talk about some of the work you're doing around future skills and maybe expand on what you've talked about already and talk about why that is critically important?
Yeah, sure. Thanks, Mark. Yeah, I can tell like a little quick story about this. So I was having coffee one day with Judy Fairburn. So I'm sure many of you know Judy. She's definitely an innovation guru. And when we had connected through our roles with She Innovates Alberta, and I was describing this need around innovation and talking about the collaboration and communication and creativity, our capacity development, our cognitive diversity, this curiosity and caring or an empathy for entrepreneurs. These are the C's, as I like to call them. And so I remember as I was trying to explain all of this, and she said to me, "Oh, you mean future skills?" And I was like, "Okay, yes, that's it. That's what we call them." So we absolutely need these future skills to future proofing or future to address our future resiliency, because our world's changing so fast. We need to change with it. But what are we doing to teach some of these skills, which is really about change? Change is it's ultimately an outcome, can be an outcome of innovation. And so there's much talk and interest and the excellent work being done through all of our innovation and tech dev teams But this side of it, the soft skills side of it, is largely ambiguous. And so I think where it draws us to is the concept of having innovation as a function. Just like you have other functions in an organization, like finance, marketing, engineering. And so I think it's really early days, but it's evolving to become recognized that we need innovation as a function. And I think organizations would be really quite well served to have that as a trained career track. I didn't go to school for innovation, right? I mean, we're all engineers, technical people, but you learn by doing, by being curious, by seeking out that change and working. I learned from working in the innovation ecosystem, by being entrepreneurial. And so, no one person can solve all these complex challenges. And so we need all these different future skills to come together. We need diverse problem solvers and create these synergistic collisions. So, it's not my work per se, but I'm very passionate about it. And I do talk about it in the terms of like the how is just as important. And as I talked about earlier, can often be the biggest barrier for breakthrough innovation is on this culture or this future skills side. So we need to find a balance of the people and the science for sure.
That's excellent. Go ahead, Cheryl.
I was going to say, I think, one of the key things is, and I think it was touched on a little bit, is not being afraid to take risks, right? That's really the big thing with innovation and having the courage to share your ideas, influence people to get the support to progress it, I think is what's really key. And then, you bring in kind of the whole inclusion and diversity as well as, I just think about my own team, right? And it's really tapping into some maybe folks that are maybe a little more introverted, but they have great ideas, is really tapping into that full team to really generate the best idea. And then, getting a champion that's going to be prepared to basically move that technology, that champion that idea through our corporate companies and stuff like that, is really important.
Yeah, thanks.
Not afraid to take risks.
Completely agree. Okay, we've only got four minutes left, and so I'm going to ask one last question for everyone in, I'd say, about 30 seconds or less. To the extent that you can, give us a teaser for what new and exciting innovations are coming next. And I mean both technological and non-technological innovations. What can you share with us in the last 3 minutes today without having to kill us? We'll start with Julian.
Okay. Yeah, we have a few things coming down the pipe for innovation and technology. We're going to start a steam additives pilot next year using surfactants. So we call those incremental technologies that will continue helping us reduce steam oil ratio and then reduce our greenhouse gas emission intensity. We have innovations in wells technologies. We continue advancing our flow control device technology. Now with FCDs that are more suitable for thermal applications. We have multilateral wells that will unlock infill opportunities at a lower cost, and now we're looking at transformational technologies that perhaps can help us reduce the carbon intensity in the steam generation, or to help us reduce our steam demand for oil production. So a lot of things coming down the pipe for ConocoPhillips and Sumo.
Great, thanks, Julian. Kyle.
Yeah, I'll touch on the surface catalytic process that I mentioned earlier. So that obviously, if we can work with our partner company to test and commercialize a process that can catalytically reduce viscosity of bitumen, that's something very attractive to us. Another one, subsurface, that's in the works right now is similar to what Julian noted. There's autonomous flow control devices. So we're in the process of testing them, and we think that there's potential for these autonomous flow control devices to improve well conformance for whether it's SAGD or EM Apex or whatever the case is. as well as hopefully mitigate some of the gas coning risks that you observed during EMAPEX or even in NCG operations in SAGD-like processes.
Perfect. Cheryl.
So I have a couple. So all of them have been supported with a government partner, which I'm thrilled about. So our enhanced bitumen recovery technology, which is an evolution of SA-SAGD. So it's basically a lot less steam and a lot more diluent, and hence a much more improved greenhouse gas emission intensity. So we're in the piloting stages there, or advancing a pilot. Another one is our enhanced late life process. So 40% of our production at Cold Lake comes from a steam flood operation. And so we're looking at moving or trialing out a solvent flood technology there. And so, if successful, it could divert, steam to higher efficient pads. So displacing steam flooding with solvent flooding. So pretty exciting. So that pilot is starting up next year. And then since I also manage mining research as well, and I know this isn't in situ, but really exciting work is going on in mining as well in our tailings program. We have an enhanced inline flocculation trial. We've had 2 pilots, and this is all to treat fluid fine tailings. Just been getting outstanding results, and it could not only result in lower greenhouse gas emissions, if you can believe it, but also avoid significant capital investments to treat our fluid fine tailings. And as part of that, we will be sharing all of that through COSIA, tailings, EPA. So really exciting activities, and we're looking to deploy that technology next year commercially at Curl.
Very exciting. Carrie, last word to you, 30 seconds or less.
Yeah, thanks. Of course, I have many amazing colleagues working in situ technology development and lots of great work being done in a similar space around solvent recovery. But zooming in a little more to a different flavor of the topic today of low carbon future and linking that upstream downstream perspective that I talked about, something that I can speak to that I'm working on is bitumen beyond combustion. I'm pretty excited about that in terms of addressing a low carbon future, and that is really new products from bitumen that are not combustion products. So it's early days with that, but I think it adds a flavor to how we address emissions in the future. And like I said, linking that upstream, downstream is really important in terms of understanding what products we would be able to make from our bitumen assets and streams.
Very exciting. Thank you very much. Well, unfortunately, that is all the time we have for today. In fact, we're 1 minute overdue. I've done a terrible job as moderator. I do want to extend my sincere gratitude to all of our panelists today, and a big thank you to those who took the time to join us for today's Lessons Learned event. As I mentioned at the beginning of the day, we'll be posting a recording of today's workshop on our website in the coming days. That's eralberta.ca. Thank you once again for joining us, and enjoy the rest of your day, everybody. Thank you.
Thank you. Bye-bye.
Thank you, everyone. Thank you, ERA.
Bye.